Alright, what I'm going to try and look at now is see if we can demonstrate that high frequency error that's introduced when you use a frequency times time piece in your equations for generating your wave. So what I'm going to do is just start a new sheet here real quick. Let's move to the next sheet, and we'll go through and do sample rate again, 44100, and let's do our time values here, just the same way we did those before. So this is equal to time before it plus 1 over sample rate, so that's an F2, and try to copy that down, select the range to A44101, enter, Control D. So what we're going to do, we'll go back to our basic sine wave here. Let's do a single wave this time. So what we've been doing before was just a standard wave with a frequency of, well, first we start with a frequency of 1, so let's just go ahead and put that in. So A1 times 2 times pi copy that formula down, and that should give us a single cycle of a sine wave. So B4401, enter, Control D. We'll just graph that right away. See if we got the results we were looking for. Alright, so we have a sine wave. There's no frequency component added. So let's look at doing frequency times time. So we have our A1 component is just the time. We need to do frequency. What I want to simulate here is what happens if the frequency changes, how that's going to affect our output here. So what I'm going to do is come up with a component for frequency, and what we're going to do is use time to create a frequency. So what we're going to do, the time is going to equal a value between 0 and 1. So if I take that time piece and multiply that by 10, that's going to give us a value between 0 and 10. What I want to do is actually have the frequency change not quite with every sample, but rather in chunks of 10. So what we're going to do is use a function in Excel called floor, which I can't spell today, F-L-O-R. And what that's going to do, let's see, so significance. This is how many decimal places it has. I think I want to put 0 there. It's been a while since I've used floor in Excel. Didn't give us an error, so that's probably what we want. Actually, we'll find out if there's an error when I do that. So we'll make our frequency 2 times 4. So, and then put our multiplication there. So what we're looking at doing here is having basically at 10 points. Well, let me go back. What 4 does is basically takes a floating point number and chops it down to just the lowest whole number. So we're going to get a fundamental. We're going to get a frequency of 0 times 2. That's not going to be very useful in our graph. So let's do 1 plus. So we'll never have 0 for any piece of that. I think that should do our trick. So this, the A portion, or the first port here, that's time, and this is just a way for me to have frequency change over time using the floor command. So let's see what happens. Do we get an error? No errors. So let's take this formula and copy that down, or fill that down. So B1 colon B4 101, enter, control D, and I got to divide by 0, error. What have I done? How can I have a divide by 0? There's no division in that formula. So A1 times 10 comma 0. Maybe I have to have this 1. Yeah, okay. Let's try that. So do the same thing, B44101, enter, control D. Alright. Now you can see that at the 10 points where the frequency changes, it jumps to random places in the sine wave. If we were to apply our high-pass filter to this, we could get all sorts of strange results. But you can see this obviously is not what we would want to see. So this is why the frequency times time component in a sound synthesizer is not the way to go. I've got about 3 minutes left here. Let's see if I can demonstrate how I ultimately chose to handle this. The actual trick is to not change the frequency, but change the flow of time. So let's see if we can demonstrate that. I'm going to pull the frequency component back out of this equation. So it is just time is the only component. That's going to put us back. I gotta copy this down. 2 minutes left. Can we do it? 44101 and control D. So we're back to that there. What we have here is a 1 hertz wave. 1 second, 1 cycle. So it turns out that if we just multiply time by frequency outside, we can actually get the same frequency curve. So what we're going to do, instead of just multiplying frequency times time, we're actually going to affect the flow of time at a different rate. So right now, time is just the sample rate divided by, or whatever the sample rate added to the previous value. Well, what if we take this 1 over frequency, let's change this to multiply it by 2. That's going to give us a 2 hertz signal. And I'm not going to have time to show you how this doesn't work. I'll have to edit something together here. So let me just plug this in and just show you that we do get oh, I copied the wrong formula. Darn it. Try it again. A 44101, enter D. Alright, so we have 2 hertz wave, and when I come back, we'll try sweeping that and see if we have any errors.